31. So we've got a colony of ladybugs that are rapidly multiplying. So the population T days from now is given by this equation AT. Similarly, a pesticide is added to another colony of ladybugs. So the population T days from now is given by this equation with the D of T. So on A, we are supposed to find the initial population of each colony of ladybugs and explain your work. All right, so what we have here is, well, when T is equal to 0, that's going to indicate that the initial population, or what the initial population is, since T represents the number of days from now. So A of 0, if I were to replace T with 0, that gives me 3,000, and then D of 0 is 4,500. So that's the initial population. Then it says on B, during what day will the growing colony, so it's important for you to recognize that the growing colony is this one, because if you're given a pesticide, then this is the one that is going to be decreasing. So during what day will the growing colony of ladybugs reach a population of 4,000, and show your work? So of course we are going to go 4,000 is equal to 3,000. We're just writing down the equation. And then now we're going to go ahead, I'm going to divide by 3,000. And so I end up getting 4/3 is equal to E to the 0.01 T. And so from here, I am going to rewrite it with the natural log. So I have ln. I don't need to write the base, but I can. ln E to the 4/3 is equal to 0.01 T. Then I'm going to divide by 0.01. And so when you do your calculator, you're going to get T is approximately 28.768 days. All right, so you would want to be able to answer the question during what day. So during the 28th day, during the 28th day, okay, the population will reach 4,000 ladybugs. Okay, on C. Okay, so we're going to do the same thing, but when it says when is it going to be halved, right? So what we want to do is take half of 4,500, that was the initial population, and we want to know when it's going to be half that. So 2250 is equal to 4,500 to the 2/3, 0.07 T. Okay, and then from here, when we divide by 4,500, then that's just going to give us 1/2, right? So 1/2 is equal to 2/3, 0.07 T. Now I can rewrite that with a log. So the base is 2/3, and then 1/2 is equal to 0.07 T. And then the difference is on this, because the base is 2/3, we would need to do the change of base formula. So in your calculators, you're going to have to go log of the argument, which is 0.5, divided by log of 2/3, get that number, and then divide that number by 0.07. And you end up getting T is about 24.42. So during the 24th day, right? Because it does say during what day? During the I can't even get that out of here. Collapse. Nope. I guess that's it. Sorry. During the 24th day, the population will be halved. And then on D, after how many days will the population of each colony have the same number of ladybugs? Well, that means you're going to want to set them equal to each other. Explain how you determine your answer based on the graphs of each function. Okay. All right. So when you have something like this, we're going to try and find out where the graphs intersect. So we need to use Desmos. Remember that each equation is its own line. So this is the first line, and then this is the second line. Finding out where they intersect, they should intersect when t is about 10.564.